We have done this lesson before, okay, because we've seen this in other chapters, okay? Compressions and stretches. Okay, we talked about this with when there's a number next to x squared, for example, okay? If a is bigger than 1, for example, it's a squeeze. We squeeze it, right? But if a is between 0 and 1, then that means we need to stretch it, okay? That makes a difference when it comes down to identifying the type of a we have, okay? This graph right here is the original function, okay? This graph right here, notice how it's a squeeze. So that means a is bigger than 1. This blue one right here, and I'll use the blue one as a matter of fact, we're going to use a stretch. So that a next to the function is between 0 and 1, okay? However, there are things that occur if the a is negative, okay? If the a is negative, whoop, it flips, okay? Notice how that flipped for x squared. For the cubic root, here's the original function, just like that. We're going to flip it in the other side. In other words, it's going to reflect across the x-axis. So instead, it's going to go like that, okay? So it flips up and down. Or in other words, flip across the x-axis. Notice that language there, boop, just like that, okay? So let's write a function with the reflection of the graph across the x-axis for this one. Well, this is just going to be negative x. Boom, just like that. This one is going to be negative radical x. The negative is outside of the function. It'll flip left and right when it is inside of the function. Okay, so let's take a look at the next example. Okay. Well, actually, let's talk about compressing. Okay. Remember how we talked about if a is bigger than 1, that means we squeeze. But if it's between 0 and 1, we stretch it. Okay. So that is for vertical compress. For vertical stretch, okay. Let me see this real quick. Vertical stretch, yes. So for 2 and 4, vertical stretch away from the x-axis, I don't know, 6x, for example, and then 7 radical x. Boom, easy, okay? Now let's do vertical compressions. Like we talked about, it's got to be between 0 and 1. So in other words, it's going to stretch. It's going to make it wider, okay? Notice how 1/2 boop and 1/2 boop, right? It stretches it, okay? The number next to a function, okay? So let's write a function that does a vertical compression. I don't know, 1/3 radical x, and then 1/7 absolute value of x. Simple, very simple, okay? Last one, or last examples. What is multiplying the input of the function stretch the graph horizontally? This is where the number inside gets multiplied by a negative. That changes things, okay? I don't want to go over this too much because it seldom ever happens, but it does change the inside though. So it basically just stretches it, okay? Horizontal stretch of x plus 2, basically it's 0.2, right? It was a horizontal stretch of 0.2, not that bad. Horizontal compressions, like we talked about, K has got to be greater, the number inside's got to be greater than 1. So let's do a horizontal compression. I don't know, like cubic root of 8x, for example. And then 4x squared. Boom, just like that, okay? That's simple. This is, again, when it's bigger than 1, okay? For this one right here, it's got to be between 0 and 1 for the horizontal compression and stretch, okay? There you go. It's simple. Look at the notes. That covers 10-5. Enjoy.